In this video, we're going to look at how to connect two different VXLAN fabrics together. So far I've just been working in one, but sometimes maybe you have two data centers or two sites you want to connect together, and this will be an example of that. And the feature is called multi-site or DCI for data center interconnect. So the links between two data centers. There's different ways to do this, and I just had chosen the back-to-back model, just no reason really. It was just one of the options. I hadn't seen anybody else really talk much about it, so we'll look at this and lab this one up. So this is the topology that we'll be using. A little bit about it is you can see at the top here in ASN 65002 in blue is one fabric, and then the green is a separate fabric. So you could pretend they're in different places or different sites. And in this example, Nexus 6 is the spine, and it's a leaf. So I had to combine the roles here just because I didn't have enough power in the lab to make it all separate. But it'll work the same because our focus is going to be on 4, 5, 1, and 2. But Nexus 4 and Nexus 5 are border gateways again, so they're leafs. So 6 is the spine, 4 and 5 are leafs, but they're border gateway leafs. In other words, they're going to get us out of the fabric. And the same is true for this 65001. Nexus 3 is the spine. It's a single spine. It's also acting as a kind of a host, it's servicing hosts, but it's the spine, just like 6. And then the leafs are Nexus 1 and Nexus 2, which they're also border gateways. And so you can see the links here that connect the fabrics together. And these are the DCI links or the multi-site links. And so this is kind of what the physical topology looks like. We're going to just pretend like this is all one tenant. So, and these are just, the colors represent VLANs. So PC1 and 3, they're in VLAN 10, and then 2 and 4 are in VLAN 20. And so we want to make sure we have bridging at the end of the day. We want to make sure bridging works over this multi-site, and then we want to make sure routing works. So 1 and 4, and we should have full connectivity of everything when we're done and with how this works. And just to show some of the separation, I have this green in its own OSPF domain. It's OSPF 1, I called it. Blue is separate. It's in an OSPF 2 domain. And then these links here, they're not running IGP, the ones in between. So these 4, we're gonna run BGP over those. So if we think about how this works at a high level, is these links, they're point to point, and we're going to build eBGP sessions over each of them. So this will advertise all the routes from one site to the other. And the trick, and this is one we've used multiple times before, is we're going to configure a shared IP on Nexus 1 and Nexus 2, and we'll just use this one for this example. So 10.255, 100.100 is going to be an IP address that 1 and 2 share, and then we're going to do the same thing on the other side. We'll just use 200 ending in 200, 255, 200, 200. So this will be loopback 100, I think. I have it. And this loopback will be advertised. They're going to advertise these to the other side, and what this is going to do, it's going to kind of hide or shield one site to the other. So in other words, when PC1 wants to talk to anything over here in the other side, when Nexus 3 does a lookup, it's going to see this green IP address here as the next hop. And so what would happen if we want to have a conversation? So 3 is going to look up the next hop, and this, since it exists on 1 and 2, it could send it to either. So let's say it sends it to 1. So here we have our first little VXLAN tunnel from 3 to 1. When one gets it, it's going to do another lookup. Well, let's just say PC1's talking to PC3. And then when one does a lookup, it's going to get that blue IP address as the next hop. And so then it's going to encapsulate it again into another tunnel. So here we have two tunnels so far. And then when 4 gets it, it's going to do another lookup, and it's going to send it to 6, but that's kind of like normal. So, backing up and looking at it, we have kind of 3 tunnels is the way that this works. And just to kind of reiterate, PC1 sends to 3, 3 does a lookup, and the next hop is the green IP. It sends it to one of these, and then it's going to do another lookup, and it's going to be the blue IP. It's going to send it to one of these, and then it's going to do a normal lookup to 6. And we'll lab all this up just to see it live, but this is what it's doing high level. As far as the configuration of this loopback 100, it's fairly simple. That exists on both of them. Now this whole thing has a lot of configuration. It's more than this, but it's just too much to put on here. But we're gonna lab it up because I don't have this labbed yet. I just have IPs on there, and I have the fabrics working in themselves, but I don't have any multi-site configured yet. Besides, I have the IP addresses. That's it, and we'll do the rest live. So let's see, another thing that this will do, this feature has kind of built in, is it has a little bit of interface tracking. So in other words, you can see that these border gateways, they have a leg here. They're connected, like this leg is connected into the internal fabric, which in this case it's only 3, but it could be more. And likewise, this link and this link, they connect inside this fabric, like they go this direction inside the fabric. In this case, the inside of this fabric is here. And there's commands that we put on these interfaces to track the interfaces. So that way, if Nexus 1, if this link goes down, if all of these links on Nexus 1 goes down, which is just one, the colored one here, if this colored one goes down, what it'll do is it'll pull that shared IP address. It'll pull it out of the advertisements, because what you don't want is stuff to send traffic to 1, but then 1 doesn't really have a way to send it down to 3. So if it stops advertising its loopback, this is going to force all the traffic to come here, which is what we want, because 2 would still work. And we'll go over this as if that's not clear with the configuration. And just like we tracked the internal side, the external side is also tracked. So we'll put a little track command on these interfaces and these interfaces. That way, if Nexus 4, if both of these go down, it will stop advertising that shared IP. It'll stop advertising it this direction, because what it doesn't want to do is it doesn't want to attract traffic here, and then it can't go to the other side and drops it. So the point here is there's a little bit of tracking here that will cause the device to take itself out of service, and that's a good thing. That way it prevents black holing of the traffic. Another key thing before we get into the lab is we do have multicast right now enabled like normal within a fabric. So it exists. There's a multicast domain here, and there's a separate multicast domain here. But when we go between the sites, there is no multicast. So this right here is not going to have multicast on it. It's going to use ingress replication, which is basically these nexuses will advertise a route type of 3, an EVP and route type 3, which they just tell each other, hey, we're not using multicast, so you're going to have to use unicast to talk to me. And that's how the BUM traffic, the broadcast, unknown unicast, and multicasts will go from one side to the other. So we need to make sure that that's working. That way PC1 will hear the broadcast, such as an ARP, those need to go cross-site. So let's I think maybe get into some of the configuration and maybe come back to this if we need to. So there's a lot going on here. It's not the most simplest thing, I don't think. So let's get to the lab. So I've got the same diagram pulled up. I'm going to try to keep it up so we can see. So I think the first thing is let's look at where some of this documentation is. So from Cisco's website, it is support, product support, switches, go to Nexus 9000. And then we have to click a switch here, doesn't really matter. And then that gets us into where we want to go to the categories. And then there's one under configuration and one under literature. So let's go configuration, literature. Under the configuration guides, I'm just going to view all. And then go to the latest version. And then there's a VXLAN right here. And then there's a site, multi-site right here, configuration little subsection. There's one, and then the other one where we clicked literature is here. And I think this is a good one. This is where I did most of my reading on it. So I'm going to keep these two up because we may come back to them just to point out some certain things. All right, so we have this fabric working already. So 1 should be able to talk to 2, 3 should talk to 4, but there's no cross communication. So we haven't configured anything on these cross links besides an IP address. So let me make sure PC1 can still talk to 2. All right, looks like it can. It's a little squashed, but... So let's look at some of this configuration. And as we paste it in, the most of the configuration is going to be on these border gateways here. And because the function has to do with them. So I've got this configuration kind of pre-ready because it's too much. It's a lot to completely do live. So I'm going to paste a little bit of it in here as we paste it in to look at it real quick, and then we'll paste it in and make sure it's doing what we think. So this is going to be the configuration for Nexus 1 right here. So the first thing is we tell it that this command here, it's a multi-site border gateway. We have to give it a number, and this number needs to match on Nexus 2. It kind of sets them together as a pair. Loopback 100 is gave that a description. That's the virtual IP address. So they're both gonna, 1 and 2 is gonna share this. And here I'm giving it a tag. That way later we can grab it and redistribute it into the BGP. And so if you just tag it later on in the route map, we'll see there's an easy way to grab the tag. And interface E11. So if we look on Nexus 1 interface E11, notice that's a internal interface. It's going towards the internal fabric. And then here's that tracking command, fabric tracking. And that's the single command that once it's on there, you know, the Nexus will know what to do when all of those types of tracks on the interface go down. It'll do some action. And then there's something similar that's going to be for the site external, which is going to be E13. So here E13 and E14 are going to have the multi-site DCI tracking. Notice that's different. There's fabric tracking, which goes inside. DCI tracking goes towards the other side. And then there's a link between them. The guide says you can use the DCI tracking for that. It sounds a little backwards, but that it said you could do that, or that said that's how to do it, and I tried to differentiate it. The border gateway internal link. This internal link is also used, according to the guide, for bum traffic. If like you have what we'll talk about later, a designated forwarder for the bum traffic, that needs to go through a designated forwarder. That way it prevents loops and it stops packets from going across twice. In other words, you just want to designate from each side. You want one of these devices to handle the multicast traffic, not both for the same VLAN, because you don't want to send the traffic over twice. So that's all the tracking. On the NVE interface, here's where we assign that loopback that we made. That's how it knows what loopback to use. And then for every VLAN we want to go across, we have to tell it, go into that, which already exists. And then we put this, telling it to use the ingress replication. In other words, there's no multicast between these fabrics here. It's going to be, everything is just going to be replicated with a unicast. So yes, it puts a little bit more of a load on the device because it has to send it out, multiple times rather than just one in a multicast, like a multicast would do. So here's the route map, called it RM tag, and we're going to match everything that has the tag on it. So we'll see how that's used right here. We go into BGP, we redistribute our directly connected interfaces, but then we specify even more specifically, I just want to redistribute the ones with the tag on it. And so the tag is important just because it helps us narrow down, and we can, so in other words, we're catching this shared loopback, and we're going to advertise it both ways. So we're going to advertise it to the other fabric and internally. And then here's how we'll modify our BGP. So notice they're in different different autonomous system numbers, or domains. So these all be an E BGP session. Again, you can see that because the neighbor is different than what I am. So there's a maximum paths 4. I think that was in the config guide. I think that just helps with the using some ECMP, because by default the BGP maximum paths is 1. We don't even have 4. I think we could use 2, but I just left it. And then this is a key field that's a little bit different. That's telling BGP this, this is what this is doing. This is for the function of multi-site. And then this is another key one. So when we think about route targets, so normally, let's see, if 6 creates a BGP update for PC3, the route target is going to be 65,002 colon something. Doesn't matter. Let's say it's a layer 2 VNI, it'd be like 110 or something. And so that's the route target. And that's going to be able to be imported and exported in the blue domain, no problem. But what happens whenever it comes over to this side is it will not be imported, because when Nexus 1 looks at its route target, or Nexus 3 looks at its route target, or 2, it's not going to match because it's looking for 65,001 colon 110. So what this rewrite does is every time these BGP updates routes comes over, it takes the 65,002 and rewrites it with 65,001. That way everything on this side is able to import it into their tables, their VRF tables. So hopefully that makes sense. So you want to rewrite that on, it's going to be on, this command is on 1, 2, 4, and 5 because it needs to be done both ways. Okay, and then last, we do have to advertise our local loopback. We give it a tag because we want the other side to know about our loopback just on the border gateways, and that's for traffic handling. And sometimes it needs to know not the shared IP, but the actual IP. So let's take all this. Let's paste this on Nexus 1. All right. And make sure it all took. Okay, so there's nothing to test really right now because there's only one. So let's look at the configuration. We delete all this. for Nexus 2. Now this is going to be just similar, so we'll go through it faster. That's the same thing, but the important thing here is this matches 1, because they're going to be partners in this process. That's exactly the same. That's the loopback shared. Here's all the tracking of the interface. You know, the IPs are already on there, but I'm just adding the tag in this case. And here we set the VNIs up for ingress replication. And then this is doing the same thing. BGP is doing the same thing. It's redistributing everything we've tagged, and it's rewriting the values, and it's putting its loopback in BGP. So let's paste this onto 2. All right, looks like that all took, I think. And then still nothing to check until we do 4 or 4 and 5. So let's do 4. So let's look at that real quick, because we'll see a couple small differences. Notice that this one is 222. So 4 and 5 are going to match there. And this IP is different. So 4 and 5 are going to share that IP. But the tracking is the same. It's going to do the same kind of tracking. It's going to do the same thing with the NVE interface, and it's going to do the same thing with the route tag and the redistribution. It's going to rewrite the route target for its favor, so that its side can pull those routes in the right VRF. And then here's its loopback. So let's take this and put that on 4. And while that is pasting, let's just get 5. So this is 5. It's this 5 is, I mean, it's almost the same thing. We've got the same IP, 222, the tracking. I mean, the IPs are different, but the tag is the important thing. There's the ingress replication, and there's the BGP, there's the loopback 0. So let's paste this into 5, and then we can do a little checking. And that's going to be most of the configuration. It's just a lot. It's just a decent amount. All right, so the first thing, let's just check some BGP sessions. Make sure all this came up kind of like we were expecting. Okay, so it looks like those are up. Well, so one has 3. So these link between the two, that's an IGP link. So I don't expect to see BGP over that. So 3 looks like they are all up and even receiving prefixes. Okay, so looks like the BGP's up. Now that's all the configuration. I just put it all kind of there at the beginning. Now we can look and see how it's working, verify it, and do a quick, kind of trace on one of the PCs. Make sure it's working like we think. So let's see, what should we look at? Let's look at Nexus 1. Let's just test it first, actually. Let's make sure that it's working. So let's see if PC 1 can talk to PC 3. Ping 10.0.0.20, not reachable. All right, so let's make sure that it can ping its gateway. If I can't remember, yeah, it does have a gateway, 10.0.0.1. Okay, so we can look at this and see why it's not working. Let's go to Nexus 3 and let's see what Nexus 3 knows about in its routing table. Show IP route VRF tenant 1. Yep, so it doesn't know, or 10.0.0.20 doesn't know about that. Let's go to Nexus 6. Let's look in its MAC address table. Let's just see if, make sure it's learning it. And E13, yep. So it's learning this. Let's see if the Nexus 3 knows about this. So let's see if the control plane is working. Okay, so the BGP part, it looks like it's working. Because 3 knows about the MAC address. Nexus 3 knows about the MAC address of PC3. So let's look at the show MAC address table here. Get this where we can see it. So it even knows where it's at. So 6809, which should be PC3. It's located out at the NVE interface, and that is the IP address of our border gateway. So let me go back to PC1, 10.0.0.20. Okay, it is working. Maybe it was just still converging. Okay, so it's working. Okay, because it looked like everything was in place. So 10.0.0.20 works. So the orange can talk back and forth. Let's see if PC1 can talk to PC4. Let's make sure that it's still not converging as well. Let's make sure, let's go to Nexus 6 and look for the MAC address of PC4. Make sure that Nexus 6 is learning. It looks like it wasn't just a second ago. It is now. So here's the MAC address from E14 being learned. So that part looks good. Now let's go to Nexus 3 and see if the BGP control plane can see this. It can see it. All right, let's look at our MAC address table again. This is 680A. There it is, 680A. Okay, let's try to ping it again. So it looks like the control plane looks all right. Let's see if PC2 can ping it. Ping 10.11.20. All right, that can, so that's a little interesting. PC1 10.11.20. Okay, we'll look at this, but PC1, it can get to PC3 right now. So here, let's do a little trace. If we go to Nexus 3 here, so if we look at the MAC address table, we can see to get to PC3, I believe it was this one. It knows to go to the next hop there. We could also look in the routing table. Show IP route VRF tenant 1. So to get to, well, I guess this would be not so much the routing table as the MAC address table. So the next hop is going to be the shared gateway between, or the shared loopback 100 between 1 and 2. So it's going to send, 3 is going to send it to one of those. So let's just pick 1. So let's look at the MAC address table now. And 60 PC3, let's make sure we're right on the MAC address. It's 6809. Okay, so here's 6809. Now the next hop changes to 200, which is the shared loopback between 4 and 5. So 1 is going to send it to 4 or 5. So, you know, kind of puts a new IP header there of this, which is going to be 4 or 5. Let's go to 4. And then let's show MAC address table 6809. Now it's going to encapsulate it again to 6. So this is what we saw at the beginning, where there's kind of a tunnel between 3 and 1 or 2, and then between 1 and 4, and then between 4 and 6. So it gets, a new IP header gets added 3 times. 1, 2, 3, and then it gets decapsulated and sent down to where it needs to go. So that's kind of how that shields everything. So if we look at Nexus 3, also what I mean, show IP route. Let's look at the BGP table, because we should see everything on the other side be reachable through this IP, which is the shared IP between 1 and 2. For the, at least for the other side. Well, 6809 is PC3. There's 2 ways Nexus 3 knows how to get to it. 1 and 2. And then when 1 and 2 get it, they should also have 2 ways. So 6809, it's got 2 ways, and the IP is the same because they're sharing it. So that's kind of how this works. Let's troubleshoot in a minute why PC1 can't reach PC4. So let's see if it's still like that. All right, it looks like it is. So maybe a routing problem, because the bridging seems to work. Let's go to Nexus 3. Let's look and see if we have a BGP update or route for that. So no BGP. We don't know about that from a layer 3 perspective. So let's see if Nexus 6 is putting it in BGP like we expect. So it's not. So there's a problem on Nexus 6 not doing the job here. Let's check the BGP sessions on this one just to make sure they're all okay. They're idle here. No, they're not. I don't know what I saw. That looks fine. All right, so show MAC address, and we're learning E14 on VLAN 20, show run interface, VLAN 20, show run interface in VE1. That looks right. That looks right. Let me go to E16 and just bounce this interface. Let me send some traffic out of it. Ping 10.11.10. I think that can reach to the other side. Yep. Let me see if I can ping 10.00.10 from PC4. So now it looks like it is pinging. So let me try again like I've been trying. Okay, so I think this was just a lab problem, because when I bounced E14 it worked. So that's kind of silly. But we can see it works now. So let's trace it from Nexus 3 just to see this is kind of the same thing. I bet if I refresh this, now it's here. Yep, so just a lab problem. So show IP route, VRF 10.1. So here we're looking for 10.1.1.20. We can see the next hop is the shared loopback between 1 and 2. So now let's go to 1 or 2. So we're looking for 10.1.1.20. Here's 10.1.1.20. Now we send it to this IP, which is going to be on 4 and 5. So if we go 4 and 5, uh, 10.1.1.20, now it encapsulates it to the loopback 0 of Nexus 6. And then by the time we get to Nexus 6, it just decapsulates it and bridges it out E14. So that's how this works. As far as, these IPs, shared IPs, kind of hiding one topology from the other. A couple other little things we can look at real quick is let's view the tracking links. For example, on one, if you want a single place where you can look and see them, you can do show NVE multi-site, and then to see the inside links, that's the fabric links. So there's only one in this case. And then you can also do DCI links. And so this is telling you every interface you have configured with those track commands that we looked at earlier. And you can run this on any of the border gateways. So if I go to 4, so there's the interfaces I'm tracking towards the other fabric. Another thing you can look at is as far as multicast. One of these we sort of talked about a little bit is the designated forwarder, which is responsible for handling the bum traffic, because you don't want, for example, PC1 to send a broadcast into Nexus 3. It sends it both ways down the multicast tree here, and then 1 and 2 both send it over. You don't want both to send it over, because then PC3 will get duplicate packets. And that could be a bigger problem with applications when they get the same packet twice. So one of them is a designated forwarder, which handles that process. So if a multicast packet if one is the forwarder and a multicast packet goes to 2 won't send it across. 1 will be the one to send it across. Now there's like an election that takes place to see which one's the designated forwarder. You can see that with show NVE Ethernet segment. And so 1 is the designated forwarder for VLANs 10, 20, and 100. And if we go to Nexus 2, which is its partner in the DCI function, the designated forwarding VLANs, it's only responsible for VLAN 1. And now the way these two synchronize, Nexus 1 and Nexus 2, they synchronize over a route type 4, so an EVPN route type 4. So 1 and 2 are talking to each other over BGP. They're sending out an update. 3 reflects it to 2. That's how they know about each other, and that's how they're able to agree on, this one. They're not split brain. They're actually syncing because this one's got 1 and this one's got the rest. And so they are able to see each other. And so here it also says they know about each other. 1 knows about 2, and then this agrees here. So they're in sync. And let's see. Yeah, I guess so. The documentation, I don't know. This is getting a little bit deeper here, looking at some of this, but you'll notice that how it seems to be distributing this is kind of odd and even. So Nexus 1 is the designated forwarder for 10, 20, 100, and then 2 is for 1. When I was playing around with this earlier, I put lots of VLANs on there, and it seemed to just, all the odd ones would go to 1 and all the even ones would go to the other. It doesn't really matter. The guide says it's round robin, but didn't really seem to work like that. So here's the guide, and so let's go to back to back, because this is what I labbed up here, and this talks about the designated forwarder. However, I'll say what this says and what I labbed up to actually work didn't exactly match up, so I'll just leave that for a little extra reading or something. So it's a little deeper. Let's not get into that right now. But this shows the topology here, where there's a back-to-back model we're using, and you can make it cross-linked here, which gives it a little extra resiliency. I think it says The minimum that you need is this square. That's the minimum that you need for this to work. And then it says you can put additional crosslinks between the border gateways. It's more resilient, doesn't require a designated forwarder re-election. So what that means, if you didn't have these crosslinks and then E13 failed, well then 2 is going to have to take over the designated forwarder because 1 can't get anywhere. And so there would be a designated forwarder re-election. But if you put these crosslinks and E13 fails, nothing needs to happen because 1 can still get to the other side via Nexus 5. So point here is there's interesting stuff to read and think about here. And this crosslink, it says it can be used for, in the case of a failure, Nexus 1 can send traffic to 2 to send across, which is what it's showing there. All right, think we'll do, let's just test our bum traffic. So that way, make sure multi-site is working. So what I'm gonna do is I'm gonna start a capture on this E13 interface because I wanna make sure it's getting broadcast traffic to make sure that our bum traffic works over the multi-site, because it should. Because as far as PC1 and PC3 knows, you know, they should think they're connected to the same switch because the semantics haven't changed. We just need to keep the semantics in place by doing all this fancy stuff. So here's E13, and I'm going to go to PC1. I'm going to ping an IP that doesn't exist because that should generate an ARP, which an ARP is a broadcast, and that should flow all the way through and hit this Wireshark. So let me go to PC1, ping 10.0.0.123, doesn't really exist. And we're getting it. So that proves the broadcast is going end to end from 1 to 3. If we look at it, yeah, I'm doing the capture here where there is no VXLAN encapsulation, but I mean, there's the broadcast, there's the ARP. So our multi-site does handle bum traffic broadcasts, unknown unicast and multicasts. And I guess the last thing we could do is just simulate maybe a failure. So on the, let's simulate on one of the tracked links. So on Nexus 1, let's note the designated forwarder is Nexus 1 right now. So Nexus 2, the designated forwarder is VLAN 1, which we're not using. So let's go to, let's shut down E11 on Nexus 1 to break this internal link. Because what that should do is if we do show NVE multi-site fabric link, that's the only link it has. So if this link goes down, we should see the designated forwarder move to Nexus 2. So let's see if we can make that happen. So shut that down. We'll simulate a failure. So Nexus 1 is going to do a few actions. It's going to realize it doesn't have a connection to the internal network here. So it should also stop advertising its shared loopback out this way because it doesn't want to receive traffic and drop it. So let's see if that's been enough time to rerun this and see if we see a change. Because before, we were the designated forwarder for 10 and 20, which is mainly what we're using. So here it's not giving me any output at all. Which that makes sense because it doesn't really have any BGP connection to 2. That this link is just an OSPF link. It's not running BGP. Let's go to 2 and rerun this. Now notice before the designated forwarder VLANs was 1. Now the designated forwarder VLANs is all. So that failover worked. So Nexus 2 had to take over because 1 lost all of its links down to the fabric. And if we go, let's go to Nexus 4. Let's look at the BGP table. Notice there's no more equal cost. I mean, there's a 10, 255, 100, 100, but before we were seeing it two times. Now we're only seeing it once. So if let's do a show IP route 10, 255, 100, 100. It only knows one way, which is to Nexus 2. So that's an example of how some of these tracking links work. When something goes down, it stops advertising that shared loopback in the direction it needs to stop it, because it doesn't want to get traffic and have nowhere to send it. So I think that's all I wanted to show with this multi-site. There's a lot to it. I think I would read these documents if something's not clear, and then the configuration guide is okay. But that is one example, and again, it's basic. We kind of stuck to the basics of how this works at a high level with the masking and the shared IPs, and how bum traffic works and goes across this multi-site DCI example.